Assalamu alaikum. Welcome to this MATLAB tutorial. In this tutorial I am going to teach you how to model a short transmission line using labels in MATLAB Simulink software. I have already made a video on the similar topic with the title on how to model a short transmission line in MATLAB Simulink software. This video is available on my YouTube channel. However, it may be noted that in that video, I have designed the short transmission line by connecting the wires with one another. This technique is suitable for small circuits consisting of 2 or 3 components. But if the circuit is large consisting of many components, then connecting all components and measurement blocks will make it extremely complex. Therefore, chances of error will be high and it will look ugly. In order to solve this problem, MATLAB has another feature of using labels in the measurement blocks. When labels are used in the MATLAB Simulink model, then measurements can be performed by calling those labels anywhere in the model without the need to connect all the circuits through wires. To design this model, I have taken an example from the book Power System Analysis by Hadi Sadat, Chapter 5, Example 5.1 as shown here. According to this example, a 220 kV 60 Hz 3-phase transmission line is 40 km long. The resistance per phase and inductance per phase per kilometers are given in the data. The shunt capacitance is negligible. Using the short line model, we have to find the voltage and power at the sending end, the voltage regulation and efficiency when the line is supplying a 3-phase load of 381 MVA at 0.8 power factor lagging at 220 kV. The mathematical solution of this example can be found in the Hadi Sadat book. For your convenience, I have uploaded the example solution in the form of PDF link in the description section. You can download it from there. Let's start. Just click on the Simulink icon to open it. Click on this icon to open a new model. First, we need to save it. You may save it with any name of your choice and in any folder. To design the transmission line model, first we need a voltage source. Click on Fundamental Blocks and then on Electrical Sources. You can see here 3-phase source block is available. Take this source block and bring it in the model. Just double click on it to put the values. Here it asks phase to phase RMS voltage, which is sending end line voltage in this case. The sending end line voltage as calculated is 250 kV as shown here. Therefore, put 250 kV here. Put phase angle to 0 and frequency to 60 Hz as given in the example data. As we are not going to perform short circuit analysis, therefore uncheck this internal resistance icon. Click on the load flow and if it is swing, then keep it same, otherwise change it to swing and click on OK. Now we have to measure the sending end voltage and current, so we need 3-phase measurement block. Take this block from here and bring it in the model. Connect it with the 3-phase source. Now we need transmission line block. For this purpose, 3-phase RLC series branch can be used to represent the short transmission line. Take the 3-phase series RLC branch from here and bring it in the model. Now double click on it to put the values. As short transmission line consists of resistance and inductance only, therefore change the branch type to RL branch. From the example, the total resistance of the transmission line is given as 6 ohm and the inductance is given as 0.053052 Henry. Therefore, put these values in the transmission block and click OK. Now again we need 3-phase measurement block to measure the voltage and current at the receiving end station. Just copy this block and paste it here and connect it with the transmission line. Now we need 3-phase load block to put the load values. Bring this block from here and bring it in the model. Connect this block here. Now double click on it, a window will open. We have to put the values for receiving end voltage, frequency and other parameters of the load. The receiving end voltage is 220 kV and frequency is 60 Hz as shown here. Now put the receiving end active and reactive power of the load as shown here. And put capacitive reactive power to 0 because our load is inductive. Now double click on 3-phase measurement block to put the values. Now this is the time to use the labels. Click on use label for voltage. You will see here VABC is written here by default. As this measurement is at sending end side, therefore just add S here for sending end. Similarly, click on use a label for current measurement and write here IABCS for sending end current. Similarly, double click on the 3-phase measurement block on the receiving end station and repeat the same procedure. Just write here R for receiving end voltage and current. Now I think we can run the simulation. Before running the simulation, we need power GUI block to run it. Take this power GUI block from here and bring it in the model. Set the simulation time to 1 second. Now we need the blocks to call these labels. Therefore we need this block and bring it in the model. Now bring the RMS block from here and again bring it in the model and connect it here. Now take the display block from here and connect it with the RMS block. Double click on the 3-phase measurement block and just copy this label and paste it here in order to measure the voltage at the sending end side. If you want to change the color of this block, right click on the block, click on format, click on background color and set the color of your choice. I choose green. Write here sending end voltage. Double click on the RMS block and change the initial RMS value to 0 and press OK. Now we need the sending end current measurement. To do this, just copy these blocks and paste it here. Double click on this block and write here IABC_S and press OK. Write here sending end current. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both results are correct. Similarly, we have to measure the voltage and current at the receiving end side. Therefore, copy these all blocks and paste it here. Double click on this block and replace S with R to show the receiving end voltage and press OK. Similarly, double click on this block and replace S with R to show the receiving end current and press OK. Write here below the display receiving end voltage and receiving end current. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both results are correct. Now we need to measure the active and reactive power at the sending end side. For this purpose we need 3-phase instantaneous power block. Take this block from here and bring it in the model. Copy these sending end voltage and current blocks and connect it with this block. Copy the display block and connect here for active power and reactive power. Write here sending end active power and sending end reactive power below the display. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both answers are correct. Similarly, we have to measure the active and reactive power at the receiving end side. Therefore, copy all these blocks and paste it here. Double click on this block and replace S with R to show the receiving end voltage and press OK. Similarly, double click on this block and replace S with R to show the receiving end current and press OK. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both results are correct. Now we need to calculate the sending and apparent power. For this purpose, we need this block so that we can easily transfer the sending end RMS voltage and RMS current to calculate the apparent power. Take this block and connect here. Copy this block and connect it here too. Now double click on this block and write here VRMS and IRMS and press OK. Now copy these blocks and paste it here. Double click on this block and write here VRMS to call the sending end RMS voltage and press OK. Similarly, double click on this block and write IRMS and press OK. As we know that apparent power is the product of V and I, furthermore for 3 phase we have to multiply it with 3. Therefore now we need product block and gain block. Take the product block from here and connect it here. Now take the gain block and connect it here. Double click on the gain block and write here 3 in order to calculate 3 phase apparent power. Now bring the display and connect it here. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both results are correct. Write here sending and apparent power. Now copy this VRMS block and connect it here. Similarly, copy this IRMS block and paste it here. Double click on VRMS block and add here R to represent the RMS voltage at receiving side. Similarly, double click on IRMS block and add R to represent the RMS current at the receiving end side. Similarly, to calculate the apparent power at the receiving end, just copy these blocks and paste it here. Double click on this block and write VRMS_R here and press OK. Similarly, double click on this block and write IRMS_R and press OK. Write here receiving and apparent power. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both results are correct. Now we are going to calculate the voltage regulation of the transmission line. We know that the formula for voltage regulation is given by Vs minus Vr divided by Vr into 100. Therefore, first we need add block. Take the add block from here and bring it in the model. Copy these 2 blocks and paste it here. Double click on the add block and put here one negative sign in order to subtract the Vs from Vr. Connect these 2 blocks with add block. Double click on this block and write here VRMS_R to represent the receiving end voltage. Now we need divide block to divide it with the receiving end voltage. Take the divide block and connect it here. Now we need gain block to multiply it with 100. Copy this gain block and connect it here. Double click on it and write here 100 and press OK. Bring the display and connect it here. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both results are correct. Now we are going to calculate the efficiency of the transmission line. We know that the formula for transmission efficiency is given by PS divided by PR into 100. Therefore, first copy this block and connect it here. Double click on it and write here P_R to represent the receiving end active power and press OK. Similarly, copy this block and connect it here. Double click on it and write here P underscore S to represent the sending and active power and press OK. Now copy these blocks and paste it here. Now copy this divide block and connect it here. Double click on this block and write here P underscore R and press OK. Double click on this block and write here P underscore S and press OK. Copy this gain block and connect it here. Now copy this display and connect it here. Now you can run the simulation. Compare the answer with the answer obtained in the example. You can see both results are correct. Friends, in this video tutorial I have discussed how to design the short transmission line using labels in order to avoid too many wire connections. Because too many wire connections are not suitable for large complex system which may lead to errors. This problem is solved by using the labels and calling these labels at any place in the model and measure the various components. That's all for today's lecture. I hope you enjoyed this lecture. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.